Students, address resolution protocol या फिर ARP की discussion हो रही है. Let's go to the slide and we'll talk about the exact structure of an ARP packet. We have got fields that are present in an ARP packet. In general, the format of this packet is that there are multiple fields and the names of the fields are pretty self-explanatory. So the first field that you see out here is the hardware type. Students, the hardware type defines the type of the link layer protocol. For example, if you're using Ethernet, then there is a particular hardware type field that is allocated to Ethernet, and that type is given 1. So we'll have 1 in this hardware type. Students, next we have the protocol type, and this defines the network layer protocol. So if you're using IPv4 or IPv6, that will be represented by a particular code out here. For example, in the case of IPv4, this protocol type field will have in hex. Students, then you have the source hardware and the source protocol addresses. They are variable length fields and they define the link layer and the network layer addresses of the source or the sender. Students, the destination hardware address and the destination protocol address fields, they define the receiver link layer and the network layer address. And as I told you, in the case of ARP request, this destination hardware address is going to be empty. So this field in the ARP request is nothing because we are essentially requesting the destination to actually send us this destination field. Students, an ARP packet that you're looking at, it's normally encapsulated directly into the data link layer frame, and the frame needs to have a field to show that the payload belongs to the address resolution protocol. Now students, एक example को study करेंगे using the ARP protocol that we are talking about, and the internet that we are going to be using for our example is what you see on the screen. Students, we have got, once again, our sending party is Alice. We have got a router R1. We have got a point-to-point network between R1 and R2. And then we have got Bob, who is our receiver. Students, first of all, we'll talk about the flow of packets at Alice's computer. In this case, as you can see, the IP address for Alice is represented by N, and the link layer address there, it's represented by L in this particular case. So students, as you can see in this case, our Alice has got an IP address of NA. This has got a link layer address of LA. The router interface that is facing Alice is N1. We have got L1 here. Then we have got N2 and L2 on the other interface. Similarly, on this end, we have got N3, L3. We've got N4 and L4, IP address and link layer address. And then for Bob, we have got NB and LB. Students, सबसे पहले, the data from the network layer, it comes down to data link layer. And in this particular case, the data link layer, what we do is, I told you that your ARP is an auxiliary protocol that's present at network layer. So using the forwarding table, the IP address for Bob is determined, and then an ARP request is sent via router R1. A unicast comes back with the link layer address LB to the sender, which is Alice. Students, in the case of data link layer, as you can see, data link layer gets its own link layer address from its interface, and it sends the data using the IP address of itself, which is the host, IP address of the destination, which is Bob's IP address. Then you've got the link layer address of the source, which is LA, and the link layer address of the next node, which is your router R1. And this frame, it gets converted to electromagnetic signals, and it gets transmitted to R1. This is what happens to start with at Alice's site. Students, the flow of activities at router R1. R1, as I told you, the router has got 2 data link layers. One that receives this signal from Alice. It then converts it back into the form of the frame and gives it to the data link layer. Once again, you see that the source address is that of Alice site, LA. The destination address is L1, and this frame goes up, the decapsulation happens, and data link layer gives this to the network layer. As you can see, the link layer header, L1 and LA, they are removed at this layer. Now the network layer again encapsulates this, and this encapsulates, once again, the ARP happens on this layer. So R1 is trying to find the link layer address of R2. So ARP happens here. Then we again encapsulate this using L2 and L3 this time. L3 is the link layer address of router R2, and then this is converted to electromagnetic signals to be sent to R2 again. Students, at router R2, same scenario. We have got the decapsulation, and then we have got the decapsulation is happening here. And then we have got the ARP. This is an ARP request that goes to Bob finally, and Bob responds with its link layer address LB. Now, the network layer of R2, that sends it to the data link layer, and data link layer encapsulates this in the form of frame again, finally with the link layer address of the destination, which is Bob. This gets converted on the physical layer to an electromagnetic signal, and this is sent to, finally, Bob. Students, at the Bob site, this signal is received. This is sent to data link layer. The data link layer strips off or decapsulates the data link layer header from this frame and provides this to the network layer. And at this stage, the network layer will ultimately strip off its header as well, and it will ultimately receive this data. So students, this is how the flow of data happens from the Alice site, Alice's site to R1, and then to R2, and then to Bob's site.